Hi everybody. So today, before we get started with our notes, I just want to review what we learned last week, give you a little bit of a preview of what our notes are going to be about so you're really focused, and I want to help you get your graphing calculator set up because it is going to be your best friend when you're doing these assignments. And taking this upcoming test on rational functions. So let's take a look at what we have here. We have the function f of x equals x minus 2 over x squared minus x minus 6. And it's a little bit different than the ones that we were working on last week because this one's going to produce two vertical asymptotes, and so we can't use that strategy that we were using last week where we could reflect our x-intercepts or our y-intercepts or a couple of points. So we are going to be using some points on our calculator. We're going to be using some points that are really close to our asymptotes so that we can figure out what the graph is tending to do to the left of the asymptotes and to the right. Okay, so let's review what we get from this the original function. Let's get all the important information that's just readily available to us so that we can get some stuff plotted on the graph, and then we'll look at the factored form. So let's look at the original form. In the original form, we can find pretty much right away what the horizontal asymptote is going to be if it's actually going to have a horizontal asymptote. So we look at the degree of the numerator versus the degree of the denominator. The degree of the numerator is 1, and the degree of the denominator is 2. And so from what we learned last week in our notes, and if you have those out, you can look at them, that if the degree of our numerator is less than the degree of our denominator, then our horizontal asymptote will always be y equals 0. And then I also told you that you can always just plug in a very large number like x equals 1,000,000 into your calculator, and it'll tell you it'll tell you exactly what your horizontal asymptote is. So y equals 0 is this horizontal asymptote. So let's go ahead and we'll sketch that into this graph real quick. I'll sketch it in so you can see it. Label it y equals 0. Okay, and that's one thing you can get from the original function. The other thing that's readily available when the function's in its original form is the y-intercept. Y-intercept just means you're plugging in zeros. So I'm going to go ahead and plug in zeros for x, and you can see that what happens is you're really just left with the constant in the numerator and the constant in the denominator, and we can reduce that, and that's 1/3. So 0, 1/3 is our y-intercept. So I'm going to just see if I can get this graph to zoom in so I can get that point graphed. There we go. And so now we have two critical pieces of information graphed. Let's move over to our factored form because the factored form does tell us some other really crucial information. We're going to start with the restrictions of this rational function. We know that our denominator cannot equal 0. Therefore, x, we are not allowed to choose x where x equals 3, and we cannot choose any x that equals -2. So our vertical asymptotes would be x equals -2 and 3. So we'll sketch those really quick, and we know that we can approach those values. Our graph will approach them, but we will never cross our vertical asymptotes. So what we're doing now is we're cutting our graph into 6 different regions, and we've got to determine what is the behavior of the graph in each of those regions. But let's take a look at one other thing. We've found horizontal, vertical asymptotes in the y-intercept. Let's take a look at the x-intercept. Your x-intercept, I know that we've denied the x-axis completely, but I think an x-intercept exists right here because the x-intercept is the 0 of your numerator when your y equals 0. That's your x-intercept, and this would make y equal 0. So that would be a 2. Yeah, I think our 0 is 2. And you could plug it in real quick to see that 2 minus 2 over 2 minus 3 times 2 plus 2. Well, that's 0 over -1 times 4 is still 0, so y equals 0. So it's definitely a 0. And so this is one of those cases where we actually are going to be crossing our horizontal asymptote. Okay, so there we go. We're kind of in a spot now where we really don't know what the tendencies of this graph are going to be. We don't know what's going to happen on the outsides of our vertical asymptotes, and really not sure what's going to happen on the insides. So let's pick some points to plug into the calculator really quickly, and then I'm going to have you set up your calculator so that we are ready to do what we're doing today. So let's try values that will just give us the tendency of the graph. So I'm going to choose -10 as my x, and we're going to see what happens as we're going this off of the graph. If we're coming from the horizontal asymptote, if we're going to come at it from below, if we're going to come at it from the top. And then let's see what happens as we come up close to our first horizontal asymptote from the left. So let's come up to, -2 from -2.001. So I mean, we are really, really, really close to that first vertical asymptote. As we come to it from the left, we'll see if that graph is going to shoot up to infinity or shoot down to -infinity. Then let's look at -2 from the other side. So we'll pick -1.999, really close to -2 coming at it from the right. Okay, and then I think I'd like to see what's happening a little bit between the asymptotes. So I'm going to choose -1 and 1 as well, just to see how that curve happens. And then let's approach that last asymptote. We're going to approach 3, but let's approach it from the left. So let's try 2.999. And then we'll see what happens when we get to the other side of that asymptote. And we'll approach it from the right at 3.001. And so that'll tell us if we're shooting up to positive infinity or down to -infinity. Then let's plug in a +10, and let's see if we're coming from -infinity above. If we're coming from above the the bottom of the. Oh, I can say this. It's coming out right now. If we're coming at the horizontal asymptote from below, or if we're coming at it from above. So let's take a look at this video, and then we'll come back and I'll have you tell me the values that I should graph. Okay, so when we plugged in -10, what we got was, yes, -0.115. So it looks like we're coming at the horizontal asymptote from the negative, so from below. So we'll make a point really close to that asymptote. And then let's check what happens as we get to -2.001. So plug that one in. And we get -800. So it's approaching -infinity as we come to the vertical asymptote x equals -2 from the left. And so this this graph is going to tend to curve and go down towards negative infinity. All right, now let's see what happens in between our two asymptotes. Let's plug in negative 1.999, and we get 799. Let's just call that 800. It's interesting that on each side of that x equals negative 2, you're getting absolute opposite values. So we know we're approaching positive infinity just to the right of the asymptote x equals negative 2. Let's try plugging in negative 1 so we can get some good turning points. I'm getting 3/4, so 0.75. So we'll graph that. Then we have our y-intercept. Let's go ahead and plug in x equals 1. I'm getting approximately 0.17, so really close to that x-axis. And then let's approach our asymptote from the left. So we'll go 2.999. We're going to try that one. And that's negative 199.8, so negative 200. About so it's headed way down to infinity. So we can really see the tendency of that section of the graph from left to right. Now we just have this last section to graph, so let's plug in 3.001, just approaching that vertical asymptote from the right, and we get a positive 200. So interesting again that they're opposites on each side of that asymptote. So coming from way up high, and then let's plug in the 10 and see what's happening, and we're getting 0.09. So really close to 0, but positive. So from the top, so we can get a little turn on there and see the tendency of the graph to go that direction. Okay, so let's scroll that in a little bit, and we're going to take a look at that graph, and it's a pretty good graph using our graphing calculator. So we're going to go take some formal notes now that you've been introduced, and let's see how you do.